Assalamualaikum. Welcome to the course of Highway and Traffic Engineering. Hi and welcome everyone. How are you today? I hope all of you are fine. I am Siti Zuraifa, your online tutor. Alright, today we will continue our lesson in applying the Public Work Department Flexible Design Pavement method in designing flexible pavements by using Arahan Teknik Jalan ATJ 5/85 Pindaan 2013. Click Enter to proceed. Before we proceed with the lesson, let me tell you about the learning outcomes of this topic. At the end of this topic, you should be able to apply the Public Work Department Flexible Design Pavement method in designing flexible pavement. In designing procedure, at the end of designing flexible pavement, there are three types of pavement we can consider. First, we can use the traditional pavement with granular base. Second, we can use deep strength flexible composite pavement with bituminous surface course. And third, we can use full depth asphalt pavement. The procedure for calculating by using the traditional pavement with granular base shown as follows. From traffic counts for the project under consideration, the information provided by HPU for the past 5 or more years, you need to determine initial average daily traffic in one direction ADT. The average should be based on a minimum of 3 days, 24 hours per day. If traffic count covers a time period of 6 to 22 hours, multiply the traffic count reported by HPU with a factor of 1.2. Percentage of commercial vehicle PCV with an unladen weight of more than 1.5 tons and breakdown into vehicle category shown in table 2.1. Average annual traffic growth factor R for CV. This is an example of designing in how to use traditional or conventional pavement with granular base. You need to determine initial average daily traffic in one direction ADT. B. Percentage of commercial vehicle CV with an unladen weight of more than 1.5 ton PCV and breakdown into vehicle category shown in table 2.1. C. Average annual traffic growth factor R for CV. You also must determine the following information from the geometric design of the road for which the structural pavement design is carried out. A. Number of lanes. From the number of lanes, you can get the value of lane distribution factor L by referring table 2.2. B. Train condition, whether it's flat, rolling, and continuous. By using table 2.3, based on train conditions, you can get the value of train factor, T. By referring table 2.2, named as lane distribution factor, you can see if the number of lanes in one direction is 1, the value of lane distribution factor L you can get is 1.0. If the number of lanes is 2, the value of lane distribution factor you can get is 0.9. From the question before, it shows that the value of L is 1.0. By using table 2.3 based on terrain conditions, you can get the value of terrain factor T. If type of terrain is flat, the value of terrain factor T is 1.0. Because from the question is rolling, so the value of terrain factor T is 1.1. For your information, load factor can be determined from theoretically calculated or experimentally measured lorry and axle load. Information from axle load study carried out in Malaysia and from legal load in Malaysia has been used as basis for calculating commercial vehicle load factor for traffic classes monitored by HPU. By using table 2.1, there is axle configuration and load equivalent factor LEF based on traffic category used by HPU. Step 2. Determine design traffic, its mean traffic category. Calculate the design traffic, that means number of axles, for the design lane and base year Y1, its mean first year of design period, using the following formula. To get value of VLF, you must refer table 2.1. From the question, the vehicle types is commercial traffic mix, so that load equivalent factor LEF value is 3.7. After you get the number of axles for the design lane and base year, you must continue to design traffic over 20 years axle design by using the following formula. To get the value of TGF, you must refer table 2. By referring table 2, based on design period data, 20 years, and annual growth 4%, you can get the value of TGF. When you get the value of axle design, you must refer table 2.5 and match with the suitable value from the list of traffic category. Because of design traffic axle is between 2.1 to 10, so the traffic category is T3. Step 3. Determine subgrade strength, subgrade category. Result from subgrade testing, you can calculate the characteristic CBR value used for design by using the following formula. When you get the value of characteristic CBR value used for design, you must refer table 2.6 and match with the suitable value from the list of subgrade category. Pavement design, in accordance with the procedure outlined in this manual, permit the use of a range of paving material provided that such as material meet the requirement of JKR standard specification for road work, JKR ISPJ/2008, Section 4. The choice of material shall be based on considerations of regional experience and ability of material and on cost. For the purpose of this manual, paving materials are classified into several categories in accordance with their intended function within the pavement structure. The categories include from top of the pavement downward. First, bituminous wearing and binder course. Second, bituminous road base. Third, unbound granular road base. Fourth, cemented or otherwise stabilized road base. Lastly, unbound granular subbase. Step 4. Select one of the pavement structure from figure 3.3 based on T3 and SG2. If you consider conventional flexible with unmodified bitumen as type of pavement, for the first layer, bituminous surface course AC10 or AC14 is 50 mm. Second layer, bituminous binder or base course AC28 is 130 mm. Third layer, crushed aggregate road base is 200 mm, and lastly, granular base layer is 200 mm. This is the example if you consider using full depth asphalt pavement as your type of pavement. From this question, you must determine A. Initial average daily traffic in one direction, ADT. B. Percentage of commercial vehicles CV. Because of traffic count covers a time period 6 to 22 hours, multiply the traffic count reported by HPU with a factor of 1.2. Average annual traffic growth factor R for CV. B. Train condition, whether it's flat, rolling, and continuous. By using table 2.3, based on train conditions, you can get the value of train factor, T. From the number of lanes, you can get the value of lane distribution factor, L, by referring table 2.2. Step 2. Determine design traffic, its mean traffic category. Calculate the design traffic, that means number of axles, for the design lane and base year Y1, its mean first year of design period, using the following formula. To get value of load equivalent factor LEF, you must refer table 2.1. From table 2.1, if your HPU class designation is buses, so your load equivalent factor LEF is 1.8. After you get the number of axles for the design lane and base year, you must continue to design traffic over 20 years axle design by using the following formula. From this question, the value of TGF is no need to refer table 2 because of the value for annual growth is don't have it at the table. So you need to use this following formula. When you get the value of axle design, you must refer table 2.5 and match with the suitable value from the list of traffic category. Step 3. Determine subgrade strength. Subgrade category. Result from subgrade testing, you can calculate the characteristic CBR value used for design by using the following formula. When you get the value of characteristic CBR value used for design, you must refer table 2.6 and match with the suitable value from the list of subgrade category. Step 4. Select one of the pavement structure from figure 3.5 based on T5 and SG3 that you get before. For option 1, you choose conventional flexible with unmodified bitumen and granular base, so that the layer for bituminous surface cost AC10 and AC14 is 50 mm. Bituminous binder or base cost AC28 is 190 mm. Crushed aggregate road base is 200 mm. And lastly, granular subbase is 150 mm. For the next step, select one of the pavement structure from figure 3.5 based on T5 and SG3 that you get before. Choose option 2 for full depth asphalt pavement with unmodified bitumen, so that the bituminous layer surface cost AC10 or AC14 is 50 mm. Bituminous binder or base cost AC28 is 200 mm. You separate it into bituminous binder cost AC28, it's about 60 mm. Bituminous road base AC28, 140 mm. And granular subbase which is 150 mm. As a conclusion, in addition to our skills in highway construction and design, knowledge of using Arahan Teknik Jalan ATJ 5/85 Pindaan 2013 cover up you about to apply the Public Work Department Flexible Design Pavement Method, how to designing flexible pavement. Okay everyone, that's all for today. I hope what you learned today will improve your knowledge in this topic. If you have any question regarding to the subtopic, don't hesitate to ask your local tutor. Hope all of you enjoyed today's lesson and see you guys for the next topic. Have a nice day.